Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to write your equilibrium constant expressions. So let's get into this. So we're given two equations here and we're asked to write the equilibrium constant expression for Kc and Kp for the following chemical equations. So first off, when we're writing the equilibrium constant expression, we got to remember that this is based on the law of mass action, which basically says that the equilibrium of a reaction is based upon the concentrations of these substances involved in the reaction. So if you add more of one substance than the other, that's going to make the reaction go either more in one direction or more in the other direction at some point, right? So that's going to be the K expression here. Now, the thing about the K expression is that it is a constant. It's the constant expression for equilibrium. So we're going to write that equilibrium is based on concentrations of products and reactants. But you got to keep in mind that it only pertains to products and reactants that are either in the gas phase or in the aqueous phase, right? It won't apply to liquids and solids. So liquids and solids won't be in the expression. So in this reaction, we have all gases, so everything's going to be in the expression. So when we're writing this, it's good to remember that, I'll write it over here, that your K expression, your equilibrium constant expression, is going to be equal to, generally speaking, the concentration of products over the concentration of reactants raised to the power of their coefficients, right? So we're going to deal with the concentrations of our products. They're going to be put on top of the expression. They're going to be in the numerator, and these are going to be in the denominator. Reactants are going to be in the denominator. So we want Kc. Well, Kc, C is for concentrations. So if we were going to express our K in terms of concentrations, then we would involve concentrations. Or if we're going to involve pressure, then we're going to have Kp. So Kp is the equilibrium constant in terms of pressure, and Kc is going to be in terms of in concentration. And the Kc is in molarity. It's got to be in molarity. And for pressure, it's got to be in atmospheres. So here's what our expression is going to look like. So for Kc, that's going to be equal to, again, the concentration of products over reactants. So we're going to have the concentration sign, so CO2. And these concentrations are going to be raised to the power of their coefficients. So here we have a coefficient of 1. We don't write the ones, but it's there. And so we would have a power of 1 on top. Again, we don't write the ones because we wrote this expression. It's there. So it's to the power of 1. So it's assumed to be 1 there. Okay, but we don't write the ones. And then we were going to multiply that by the concentration of the H2 gas, so H2. So again, whenever you have square brackets around a substance, that means concentration of. And so here we have a 3 coefficient, so this is going to be raised to the power of 3. So we're going to put a 3 up there. And then now we're going to do the reactants. Reactants are on the bottom. So it's going to be the concentration of CH4, methane. And again, it has a coefficient of 1, so we're going to raise that to the 1 power. Again, we're not writing ones. And then we have the concentration of H2O. And then that has a 1 coefficient. So that's also going to have a 1 power or 1 exponent. So again, it's going to be 1. We don't write the ones. So this would be the expression of Kc. Kp is going to be very similar, but we're going to use pressures. So when we write the expression for Kp, it's going to be in the terms of pressure. So, but everything else is pretty much the same. So it's going to be products over reactants. So it's going to be the pressure. We'll put P for pressure of CO2, and we'll put CO2 on the bottom there. So we got the pressure of CO2, partial pressure of CO2 in this case, multiplied by, and it's going to be the partial pressure of H2, but that's going to be raised to the power of 3 because we have a 3 coefficient. Here again, raised to the power of 1, but we don't write ones. And then we're going to do the reactants on the bottom. So it's going to be the partial pressure of CH4 multiplied by, and again, this is one coefficient, so it's raised to the power of 1. And then we're going to have the partial pressure of H2O gas. So that's H2O. And again, raised to the power of 1 because we have a 1 coefficient. Okay, so both of these are the expressions of the equilibrium constant in terms of concentration and in terms of partial pressures. Okay, next we have our next equation. So again, we're going to write the Kc and the Kp for these. So again, Kc is going to be in terms of concentration. So we got Kc. And again, we're going to have products over reactants. So it's going to be the concentration of the products multiplied together and raised to their respective, the powers of their coefficients. Okay, so here we have SO2 gas. So we'll have the concentration of SO2. And since this is a 2 coefficient, it's going to be raised to the power of 2. And then that's going to be multiplied by the concentration of H2O gas. So H2O raised to the power of its coefficient, which is, again, 2. And then on the bottom, we're going to have our reactant. So here we have H2S. So it's going to be concentration of H2S. And again, that's raised to the power of 2. So it's going to have a 2 coefficient, power of 2. And then multiplied by the concentration of oxygen, O2. So we'll put O2 in there. And then this has a coefficient of 3. So this is going to raise to the 3rd power of 3. And so this is the Kc expression for this reaction. So next we have the Kp. So Kp, very similar. The only difference is that it's going to be in terms of partial pressures since we have all gases. So again, products on the top. So we're going to have the partial pressure of SO2. And then that's going to be raised to the power of 2 and multiplied by, again, the partial pressure of oxygen. And so, or I'm sorry, not H2O water. So we're going to have P of H2O, and that's going to be raised to the power of 2 because we have a 2 coefficient there. And then we have the 2 reactants on the bottom. So partial pressure of H2S. So we're going to write P H2S, and that's going to be raised to the power of 2 because it has a 2 coefficient. So that's going to be a 2. And then finally, we have the partial pressure of oxygen. So we're going to multiply that by the partial pressure of oxygen. And that's going to be raised to the power of 3 because it has a 3 coefficient. And that, ladies and gentlemen, is the Kc and Kp for this reaction. And that is how you write the equilibrium constant expressions for any reaction. So again, it's going to be the reactant or the product concentrations or pressures raised to their respective coefficients, the powers of their coefficients, and then divided by the concentration or pressure, partial pressure of the reactants raised to the power of their coefficients. And that's all you need to do. And so if this video is helpful, if you enjoyed this video, if it was helpful in any way, then please like the video, share the video with your friends, hit that like button. Also, subscribe to my channel. Make sure when you do, you click the what do you call it? The notification bell. And when you do that, make sure you click all so you can be notified by all videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you want me to help you with, put that down below. As well as if you have a topic you want me to cover, put that down below as well. I would love to do that for you. Thanks for joining me and have a great day.